Hello, is there anybody there? We are trying. We are talking to Dr. Nail, and he's trying to connect and join this live broadcast now. Hello, can you hear me? Hi, hello.
That took a little time.
How are you? And finally, we have get in touch with you.
That's funny. Took a little time. What can I say?
Oh, sorry for the disturbance, but we thought you were busy and you cannot confirm this, and we were planning to make an advertisement for this event, so we can have many viewers, and yeah.
Well, glad we can
Hello.
do it. That's awesome.
Yeah. Hello. Uh, first of all, can you tell us about the passion that made you choose to be a paleontologist?
The question is about, what's the passion that led me to be a paleontologist.
Yes.
Really what the whole thing is for me is about discovery. That one of the great joys of being a scientist is to be able to discover, to learn about the world. And the thing about paleontology is so appealing to me, as when I was a student, was the fact that you can go to a place in the world and find fossils that tell you important things. And so I see a life in science as a life of exploration. It's a life of discovery of the world. And there are all these beautiful mysteries, in the world we live in. And being a scientist, you can answer some if you're really lucky and work really hard. You can actually answer them. So that's sort of what led me to this career. And the reason why I like paleontology so much is because it gives us perspective. It shows us that the world we live in today is not how the world always was. That there were times when there were no people. There were times when there was no animals. There's times that there were, all kinds of crazy creatures out there. And And I think what it does is it lends us a perspective about the past and how the past actually shaped us. So for me, that's what it is.
So you want to discover ourselves through the fossils and the creators that have lived in the past.
Yeah, most definitely. And so, and what it shows is that, and I guess this is also powerful to me too, and this is what led me to write the book, and the TV show and all that, is when you study science, the sciences that I study, paleontology as well as DNA, what you learn is just how connected you and me,
Yeah.
we're connected as people, as life. And all life shares those connections. And once you see that, you gain a certain respect for how close we really are, and it does affect your worldview. And I think, that we're connected to each other, we're connected to other living creatures, we're connected to the planet, and we can show this through our history. Whether it's the history of Earth or the history of life, paleontology and geology show us it.
Okay. In order to find out your kind of treasures, the fossils, as you have called them in your documentary, you have to go to distant parts of the world, from the Arctic parts of Canada to South Africa to Ethiopia, being in a new place every time. Is that part of discovering other aspects of our world?
Oh my gosh, yeah. I mean, nothing. I tell this to my children. Nothing changes the way you see the world better than travel. When you travel, when you're forced to live in other, you gain a new appreciation. It's one thing to read about something in a newspaper. It's another thing to see and interact with the people, and it changes the way you see the world. So when you're a scientist, when you're a geologist or a paleontologist like I am, traveling to Ethiopia or Canada or South Africa, or right now we're planning to go to Florida, go to the South Pole. All that changes how you look at the world. The world becomes a smaller place. All of a sudden you start to see, the history in Ethiopia, the history in Greenland, the history in the United States, the history in South Africa.
Yeah.
But you need to see the rocks as part of a similar global phenomenon.
So you love that?
Oh, gotcha.
Yeah. Like what Saint Augustine once said, that the world is just like a book, and those who don't travel will see just a one paper of it.
Yeah, they might see one sentence. That's about it, and it does change the way you see
it. Yeah. So to the third question. In your work on fossils, you have worked with geologists as well as experts in anatomy. Do you think that collaboration between experts from different fields of science is becoming more prominent feature of scientific research nowadays?
Most definitely. It's collaborative. Right? So just as you were just saying, science is international. Science is very international, but it's also collaborative. That is, no one person has all the expertise to answer everything.
Yes.
So the science that I do and the science that I'm going to do, it always involves a team of people with different expertise. Biologists, anatomists, molecular biologists, stratigraphers of different kinds, people who know how to work in the so everybody it's a team where everybody brings their expertise, and together we're better.
Okay. In your inner fish, we learn about the features we have in common. With comparative anatomy and embryology. Therefore, we hear about the gills, gonads, and the consequences of our developing gonads in the abdomen first, and how that can cause hernias in human beings. Evolution is always a sign of improvement, or it can have some drawbacks.
Well, evolution, it's hard to look at it as improvement always, in the sense that organisms, creatures are always adapting to their immediate environment. That doesn't mean they're better, So, you can always look to say, you can compare me to a bird, Okay? You can ask the question is, which is better, heel Shubin or a bird? Well, okay, I can talk to you right now. I can use my iPhone. I can't fly. I can't breathe on the top of Mount Everest. Birds can do that.
Right. So the
organisms become specialized to their environments. Now, break it down even further. It doesn't always mean that organisms, as they evolve, are improving. Okay, sometimes organisms, as they evolve, will lose structures, will lose limbs because they're specialized in a different environment. So when you think about an animal that evolves to live underground, the animal that evolves to live underground, they often lose their eyes. Is that an improvement?
Yes.
Well, yeah.
No.
If they want to live underground, it's an improvement. But if they want to live on top of ground, it's not an improvement. So it depends on the context. That's why we can't always describe it. We define it to a particular environment.
Okay. So can we say with your discovery that tiktaalik fish had a solid proof to fill the gap in the transition point from a fish to an amphibian?
Yeah, so we had pretty good, we had really good fossils before. I mean, tiktaalik's not the only one. What's great about tiktaalik is just how well preserved it is, how many specimens there are, and kind of what it tells us about the details. But, we knew from DNA and we knew from other fossils that the closest cousins of limbed animals are lots of lobe-finned fish. And there are some lobe-finned fish that are pretty cool. Before tiktaalik. No, so it's just one of several lines of evidence. It's one of several. It's not the only. By no
one of several.
Yeah, one of many.
So, in your inner reptile, we learned that we have an egg-laying legacy of broken genes that are responsible to form yolk. You call that fossils from the past. Can we say that embryology and genetics carry many key answers to our questions as regards our origins?
Oh my goodness, yes. And one of the things about it that's so important is we now have technology where we can look at the genome of creatures as different as flies and people. And I can compare our genes directly to a fly. And we can ask the question, how are the genes that build the body of a fly different from the genes that build the body of a human? I can answer that for a fish. How are the genes that build the body of a fish different from the genes that build the body of a human? So we can now get down to the similarities and differences among creatures at genetic level. And what it shows is very powerfully is the genes that build skin are pretty much the same as those that build our hands, fingers, and toes, our limbs. So if you look, you see what we find is the pattern of evolution we see is underwritten in the genes. Shows just how similar genes are seen in all these different critters and how it seems like a big evolutionary step really involves relatively, modifying similar genes in different creatures in other regions.
Okay. So, again, with your inner reptile, we know that we have inherited our teeth, skin, and hearing sense from those ancestors, and that skin folding has led to the formation of scales, tethers, and eventually mammal glands. Does that make us more related to reptiles than we used to think?
So wait a minute, is it more related to reptiles? I didn't catch that last word. More related to reptiles for what?
The feathers, the folding of skin that lead to the formation of the feathers, the scales, and the mammal glands eventually. So are we more related to reptiles than we think?
We are very much related to reptiles. So we can actually look at the evolutionary sequence from reptile to mammal and see how the transition of the jaw and the ear and the teeth have evolved. That's actually a very beautiful story. And it's supported by so many lines of evidence, from the lines of evidence of the fossils to the DNA to the embryos. We're very, very closely related to reptiles. In fact, if you look at creatures that are over 200 million years old, some of them you'll be hard-pressed to tell which is a reptile and which is a mammal. That's how finely. So the difference between reptile and mammal when you get to that time frame is just so fine that you or me, if we looked at it, we'd have real arguments about which is a mammal, which is a reptile, as they start to integrate with each other. So,
yeah, I think this can be found in the mythology and how peoples are connected to the dragons and the,
oh yeah.
the
In terms of mythology.
figurines with child heads. Yeah.
Exactly.
Yeah, I have noticed that you suggest our ancestors evolved in burrows, escaping the persecution of dinosaurs, if we can say that. Does that nocturnal lifestyle force us to evolve our middle ears and its three bones, malleus, ancus, and stapes? And can we say that the mass extinct of big reptiles made us a favor to conquer the air?
Yeah, so I mean, to get back to that one, I think, it's kind of one of the big patterns of evolution is with the extinction of the dinosaurs 65 million years ago, our distant mammalian relatives really took advantage of that. So,
yeah,
one of the great events in our history is the extinction of many groups of reptiles. So, if it's not for their extinction,
okay.
So, their extinction made our world possible. In a large way. I mean, if you look at the evidence, it does seem to suggest that. Otherwise, if you look at early mammals, our ancestors, there was a real emphasis on feeding, much better teeth and refined teeth, but a much refined high-frequency hearing. So it may very well be that life in nighttime, nocturnal environments where hearing is at a premium may have been very important.
Okay. In your inner monkey, we learned how living on trees played a role in developing our marvelous hands, and how the necessity to eat ripe fruits helped developing their own to have a wide range of vision. As a drawback, this gave us a weak sense of smell. You have also mentioned the drawbacks and advantages of our spine curves, as well as the long childhood. Is this a proof that evolution is a way to make creators capable of meeting his needs and not a way to be perfect? I think it's similar to the previous question.
Yeah, I broke apart. I didn't hear you because you broke apart in the previous. I didn't get the question part. I heard your statement, but not the question.
Okay. We talked about the advantages and disadvantages of our evolving into mammals, and the curves of our spine, the developing of the rods and cones to distinguish between the ripe fruits and others, and that this at the same time give us a weak sense of smell. So we are evolving something and losing others. So the same question that we are not going to be perfect, but to meet our needs.
Yeah, we're definitely. Look at if you look at the leading causes of death. Let's just take the United States. I don't know.
Yeah.
Leading causes of death are diseases related to a sedentary lifestyle and old age.
Okay.
Our evolutionary history has led us to a point where we evolved in very active settings, active animals. But I spend most of the day sitting in a chair. We eat very rich foods.
Yes.
Many of our bodies are not designed for the modern world. They're designed for past world. And so that's why there's this disconnect between the present we live in as humans, our bodies, and the past we arose in. And so that disconnect means we have all kinds of problems. I mean, we've got them. Our knees fail, our backs fail, our metabolisms don't work for the kind of
Yeah.
As we get older, we get susceptible to all kinds of diseases that really probably did not impact our ancestors all that much. I mean, I can't imagine that our ancestors who lived to the age of 30 suffered a lot of cancers. Right? Because that's pretty young.
Okay. In your visit to Ethiopia, you have told us that our ancestors, Adi and Lucy, do they represent the most related ancestors to our species, Homo sapiens sapiens?
Well, they're very informative. I mean, the thing about them is that, you know, they're successive ages. Now, there are a lot of fossils. They're not the only ones. There are lots of fossils out there.
Yes.
A ton, actually, that speak to human evolution. What's great about those is they show the sequences of ages that are likely evolved in the origin of life. After Lucy was, you know, the initial impact of Lucy was really showing, but of the human existence, bipedality, walk on two legs, really first. And so that's why those are very important, because they show the sequence of stages that are important in the evolution of humanity. You know, big brains, walking, the ability to masticate, so forth. All these things are important human traits. But of those, it appears that bipedality, the ability to walk on two legs, that happened pretty early. That's, you know, you can thank those fossils for it.
Okay. You have shown us that Amphicoelus is the last.
Amphioxus.
Amphioxus, yeah, sorry. Amphioxus in the last episode. This reminds me of studying that creature at high school in Iraq. It was presented as an example for primitive nervous system, with all these anatomical, biological, genetic, microbiological, and physical proofs for us about our common ancestors and evolution. Do you think it is logical to keep the debate in many places all over the world whether this theory is right or not?
Yeah, so that debate, quote unquote, was over in the 1800s. Okay, we no longer debate whether the Earth is round or flat. Right, that debate is. Yeah. What happens is we as humans, we learn and we have debates at a time, and then we move on. The debate about evolution is for all intents and purposes over, whether it happened or not. So we have lots of evidence from DNA, from fossils, from geology that show that evolution is a fact of life. We can see organisms evolving today. We have solid evidence to show that creatures have evolved in the past.
Yeah.
What doesn't mean is there are still very, very, very prominent debates in evolution about how it happened. You know, that happened is no longer under work of debate by anybody who is serious about it. But
so it's not acceptable in scientific. I mean, these debates are not acceptable in scientific.
I mean, look, if we were to have a debate right now over whether the Earth is flat or round, it would be a very good debate. It'd be a waste of our time, because I would show you satellite photos. I'd show you the Apollo mission from Apollo 8, where they took that beautiful image from the moon to the Earthrise. You'd see all these beautiful things. The only piece of the debate would be where somebody would say, well, maybe that's all a fraud. Maybe that's all fake. I mean, that would be the thing. It wouldn't be useful. That would not be good. Nobody would learn anything in that debate. I think the same is true with evolution. That evolution happens. We can watch it in the lab. We can watch it. We have DNA to show. Exactly. We can actually mimic it. I can manipulate the DNA. Reproduce things. So.
And the mutation that happened in the bacteria, we can see that as a fact.
There's no doubt. We can see mutations happening in our own genomes. We can show how we can look at human populations, compare their genome, and show that the signature of natural selection is present in your genome and mine. You know, that's the amazing. That's where the genetic evidence is very beautiful. Is we can actually see that. You know, we can see human evolution, natural selection, the impact of natural selection on human genomes.
Yep.
You know, oh, yeah. I mean, I don't think it's a productive debate. We're not going to learn anything from it. There are productive debates. That's not a productive.
Yes. Okay. So, why the religious people concentrate on debating the evolution theory, and they don't give that much interest debating the Big Bang theory, for example?
They don't give what?
The Big Bang theory.
Yeah, I don't study the Big Bang Theory, so I can't comment in detail about it. But yeah, it's I think I mean like any evolution is very.
Both of them can affect their beliefs, I think.
Yes, evolution I think. Yeah, so evolution has an immediate threat because what it shows is the antiquity of the Earth.
Okay.
And it shows that humanity is very special. Let's face it, humanity, we can talk, we can think, we have powers and so forth in many ways. But we're not fundamentally different from nature. We are nature. We're part of nature. We're connected to nature.
Yeah.
We're different from nature. And so I think one of the great threats of evolution historically, evolutionary thinking historically, is this connection that we are of nature, that we're not a special creation. Yeah, and if you take a literal reading of certain scriptures, that's going to be very threatening. Okay. So I'm not going to tell you.
One of the most claims they said when debating this theory that it cannot explain the beginning or give us how the first cell evolved.
Well, I don't know about
that. How can we respect
there's a couple lines, so we weren't there, so there's no fossil evidence for the origin of life. But we're getting very close to showing that if you have the right conditions, replicating molecules can arise spontaneously, under the right circumstances. So, I would argue if you come back in 10, 15 years, I mean, people are going to have good experimental evidence showing the plausible conditions for the origin of life. And the critical thing is to transition from non-replicating material to replicating material, and then cellular replicating material, that those things are possible. And given what we've learned about physical chemistry, the biophysics of membranes, how enzymes work in replication, I think those, as we break down those problems, they're not going to seem so
scary. Okay. And finally, what do you think of independent initiatives like the Iraq Translation Project that are based on volunteers dedicated to bring science and knowledge, especially in undercovered the region, to Arabic-speaking communities?
I think it's a great privilege to be involved with you. That's why I loved it, the chance to do this, because I think the more we have people out there communicating ideas, the power of ideas, the power of science, the power of evidence, all I think it's essential. Because we scientists just can't talk to each other. We have to talk to the world.
Okay.
One way we can talk to the world is like you. So thank you for what you do.
So you think that social media can play a role in making science more popular?
Or more widely known. I think it's, whatever it is, we have a problem. And that problem is that science is not as widely appreciated as it should be. But it's not just science, it's evidence. How we understand evidence, how we evaluate the importance of them. The more voices we have out there, for more communities, the better. So I think it's a great thing. Yeah, again, thanks.
Okay. So what's your advice to those young people and the youth in the Middle East and North Africa?
I think stay curious about the world. To know that what kids have nowadays is they have a world of information at their fingertips. Whether it's on their phone, you have entire libraries on your phone. That's such power.
Yeah, exactly.
But that power is enormous. And so really what the first step, being able to unlock the power in your phone or on your computer or what have you, the vast knowledge, be curious. It's to follow your curiosity. What defines a good scientist is having questions. Always question. Question. That's what I encourage kids to do. Always. That's what kids do so naturally, by the way, is they question. And about the world. And what you'll find is that there's for centuries, humans have been making fabulous discoveries. For centuries, humans have discovered great things. We've walked on the moon. We've looked into the DNA. We've done amazing stuff. And I encourage kids to explore that, as they now can.
Okay. Thank you very much for having this opportunity. We do appreciate that.
My pleasure, of course. Keep up the good work.
Okay. Okay. Thank you.
Here, bye-bye.
Goodbye. Goodbye.